Alright guys, here we go with f.bf.2, learning target 2.1. So in this one we're just dealing with those recursive formulas, and we're going to do it from a pattern. Okay, so we've got just the sequence pattern, a set of numbers. We also have some more visual patterns that we're going to be taking a look at here. But the idea is making sure we understand the parts of a recursive formula. Okay. Now, recursive, remember, it connects outputs. Okay, so we go from one output to the next to the next. So, to get that next output, that next term, well, it's equal to the previous output, and then we apply the pattern. Okay, kind of goes like this. If we look at this problem right here, to get from negative 28 to 2 to 32, we're adding 30 each time, right? So if I want to get to the next number, what do? Well, I take that previous term, 62, right there, and then I do what to it? I add 30, which would be adding right here, okay? So that then we get 92, which was the next output. Okay, so looking at that, that's what it's modeled after. Okay, now the other thing we need to know with the recursive was we need to know where that zero output was, that zero term. Okay, now we don't like to write them out like this, so mathematically speaking, that next output right here becomes a sub n. Then the previous output becomes a sub n minus 1. That n just represents which term they are, and it just makes minusing 1 takes it back to the previous term. Okay. Then the growth. Okay. Now, if it's arithmetic, remember that's a plus or a minus, so we add or subtract the growth. Okay. Now, if it's geometric, that would be a multiply or divide the growth, okay, depending on what type of situation we have. So, then the last idea is that zero term, okay, not the first term. And the trick, I think, on these sequences is that's the first term, okay. So we actually have to go back here and go back one to get to the zero term, okay. So we'd apply the pattern backwards. And we get negative 58, which would be the zero term. So then a sub 0 would equal negative 58. Okay. So with the recursive, those parts are always the same. Okay. Now we could actually, if we really wanted to, make this a sub 1 and do this as 28, negative 28. That is possible to do. But when we're dealing with recursive and explicit equations together, that a sub 0 is the better option. So that's why it's something we want to get used to doing. Okay. Also, keep in mind that when we're talking about recursive a sub n, we can write that as f of n or f of x, and a sub n minus 1 becomes f of n minus 1 or f of x minus 1, then plus the growth. And then instead of a sub 0, it's f of 0. And that would become negative 58. So there are other ways to write it. But those are kind of the basics with that recursive formula, so let's go do some problems. We kind of already did the first one, didn't we? So let's write that one down. So we had a sub n equals a sub n minus 1. And then we found the pattern was adding 30, an arithmetic pattern. Then a sub 0 going back to that 0 term. We ended up with negative 58. So what it really comes down to, because in the recursive equation, this part is always the same, we just need those two parts. We need the growth, we need to know if it's arithmetic or geometric, but then the growth, and then we need to know where our starting number is. So on all of these problems, that's what it comes down to, is making sure you know how it grows and where it starts. And everything else is the same. So number 2, if we take a look at this, okay, again, growth starts. So that's what we're looking for. Just remember, unless it tells us that's the zero term or the beginning, we assume that that's always the first term, okay? So our first trick is to probably figure out how the growth is. So 30 to 24 to 18 to 12 looks like we're subtracting by 6 each time, okay, making this arithmetic. So if we go backwards, that would mean our starting number is 36. So then going in, a sub n equals a sub n minus 1. We're subtracting 6 each time. And a sub 0 equals 36. So there's our start number. Okay, and that's all there is to it, guys. So thinking about how we always start it out the same, honestly, whenever dealing with recursive, we could go through and we could just start out by writing how it starts and how it grows. And then we just look and say, okay, 12 to 19 to 26, we could be adding 7, which if I test those, yep, we're adding 7. So there's my growth. Then if I go backwards from 12 and subtract 7, my zero term is 5. So I end up with 5. And that's all there is to it on these. It's just the main point, I think, is just remembering how to write it all out. Okay, I think that's probably the toughest part here. So number 4, negative 26 to negative 34 to negative 42 to negative 50. Looks like we're subtracting by 8 each time. Okay, so that's our growth, subtracting by 8. So if I go in reverse order, that would take me down to negative 18. So a sub n equals a sub n minus 1 minus 8, and a sub 0 equals negative 18. All right, let's just keep on trucking here. So negative 38 to negative 40 to negative 42 to negative 44. Pretty easy to see we're subtracting 2 each time. Okay, so a sub n equals a sub n minus 1 minus 2. Then if we drop it back and add 2 to negative 38, we get negative 36. So that's our zero term, negative 36. Okay. Now, when you're dealing with recursive, it is all right to start with the first term. Okay. So if I were to do that, look at number 6. So it looks like we're adding 3 each time. So my growth, a sub n equals a sub n minus 1 plus 3. Okay. Normally we do the a sub 0 equals. Okay. But if you, in this case, you really could just go a sub 1 equals 17, and that would still work just fine. Okay. But I like to get in that habit of going backwards and figuring out the zero term, because typically we're not just doing the recursive, we're also doing the explicit as well. When we're doing the explicit, we want the zero term. Okay? All right, so let's see, we've got 6 more here. So now 64 to 16 to 4. So I could say, okay, we're subtracting 48. But if I subtract 48 from 16, it's not going to get me 4. That tells me this is not arithmetic. So then I'm going to test to see if it's geometric. So how can I go from 64 to 16? Well, if I wasn't sure, okay, I could take 16 and divide it by 64. And that gives me 0.25. Okay, what that means is that I'm multiplying by 1/4, or in other words, I'm dividing by 4. So there's 2 ways you can do the recursive when we're dividing. Okay, you can put divide by 4 here, or you can put times by 1/4. Okay, either one of those will work in recursive. I would probably get in the habit of doing the times by 1/4, just because when it comes to explicit, because we always want to keep in mind explicit, as I've said. When it comes to explicit, we want to multiply instead of divide in the explicit equation. But dividing by 4 is perfectly fine. So then if I'm going back to my zero term, I would just multiply by 4. So I'd start out at 256. Then we divide by 4 to get 64, then 16, then 4, then 1. Okay? All right, number 8. So 2 to 6 to 18. Okay, again, I could say I'm adding 4, but 6 plus 4 is not 18, so it's not arithmetic. So what else could I do? I could times by 3. And if I do that, I can see then, yes, that's my growth. I'm timesing by 3. So going backwards, I would take 2 and divide it by 3, which, if you're using a calculator, that would give you 0.6 repeated, which is fine to use that, okay? Or to just use the 2/3. So a sub n equals a sub n minus 1, and we're multiplying by 3. Again, remember this a sub n minus 1 is just a term, and it means the previous term, okay? And this means the next term. And then the a sub 0 means the 0 term, which we said was 2/3, or you could write it as 0.6 repeated, okay? That works as well. All right, number 9. So 4 to negative 16 to positive 64 to negative 256. When it goes positive to negative like that, back and forth, that's a pretty good indication it's not arithmetic. So let's check to see if it is geometric. So 4 to negative 16, we'd times by negative 4. If I times negative 16 by negative 4, that does take us to positive 64. That's our growth. A sub n equals a sub n minus 1 times a negative 4. Okay? Then a sub 0 equals, well, if I go 4 divided by negative 4, 4 being this 4, that being that 4, it's a negative 1. So we start off at negative 1. Okay, number 10, 2, 4, 8, 16, 2 to 4. We could add 2, but that wouldn't take us to 8. That'd take us to 6. So we got to be timesing by 2 here. So a sub n equals a sub n minus 1 times 2. Then a sub 0 equals, if we go backwards, 2 divided by 2 is not 0, it's 1. Okay. Remember, if you're doing geometric and there's multiplication involved, to go backwards, it's division, not subtraction. All right, number 11. Again, we've got that the multiplication to, or positive to negative, negative to positive, 3 to get to 9. We could times by a negative 3. 9 times negative 3 would get us to negative 27, so there's my growth. Times negative 3. Then where do we start? Well, if I take this 3 and divide by this negative 3 over negative 3 is definitely a positive 1. So we start out at a positive 1. A lot of times with geometrics, we like to start at 1. Okay, much easier than those fractions, isn't it? Okay, and then finally number 12. Negative 2 times negative 6 times negative 18 times negative 54. It's kind of like that one, isn't it? So we're timesing by 3 again, okay? Because they're all negative, we have to multiply by positive 3. So a sub n equals a sub n minus 1 times 3. A sub 0 would equal, going backwards, negative 2 over 3. Or we could write that as the decimal, negative 0.6 repeated. Okay, and that's all there is to it when we're dealing with these sequences, okay? Which a story problem we can create sequences, and even a pattern we can create sequences. We can kind of do the same thing, basically, with these, okay? So looking at 13, we've got step 1, step 2, step 3. So we're going to need to go back to step 0. Okay, that'll be our beginning. Notice how this one over here says at the beginning, whereas this says step 1. So 0 term, first term. You've got a first term. You've got to pay attention to those, okay? So we go from 1 to 4 to 7. So it looks like we're adding 3, aren't we, each time? Because we're adding one box on each appendage. So going backwards, I know this won't make a whole lot of sense, but we'd have negative 2 boxes. So a sub 0 equals negative 2, and a sub n equals a sub n minus 1 plus 3. There we go. Again, it's all about finding the growth and finding where it starts. So here we already got the start. A sub 0 equals 1. That one was easy, wasn't it? And then after 1 minute, we have 5. So we go from 1 to 5 to 9. So here we're adding 4 each time, or 1 dot each time. So a sub n equals a sub n minus 1 plus 4. Okay, that one should look familiar too. All right, number 15. So we start with, we want the number of sides and middles. So middles meaning these. So 1, 2, 3, 4, 5. So figure 1, we have 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay. Oh, why did I say 5 at the beginning? There's 6, isn't there? Okay, so one way we can look at this is we realize that with each figure we're adding that amount, right? We're adding 5 and 5 are 10. So 2 of those, we're adding 10 each time. So there's our growth. Then going backwards, 6 minus 10 would have us start at -4, which really doesn't make sense, but that's how we're starting. So a sub n equals a sub n minus 1 plus 10, and a sub 0 equals -4. Okay, number 16, we start with 1 box, then 3, then 5, then 7. So pretty easy to see we're adding 2 each time. So going back to the 0 term, we would have 1 minus 2 would give us -1. So a sub 0 equals -1. A sub n equals a sub n minus 1 plus 2. Okay? So, not sure if you prefer the sequences or the pictures, but you can flip-flop and notice that a lot of these I kind of made the sequence to help me see it. So you can definitely take these and sometimes make a picture or think about it visually to help out with that. Alright, let's try the last 4. Okay, number 17. So at the beginning we have 3. Then after 1 minute we have 6. Then after 2 minutes we have 12. So we're definitely not adding 3. So how about timesing by 2? Doubling each one? Yep. And we begin with 3, so a sub 0 equals 3. A sub n equals a sub n minus 1 times 2. Okay, if we look at 18, the first step, we have 1, then we have 4, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 1 to 4 we could add 3, but that wouldn't get us to 16, so we're definitely timesing by 4. Okay, so a sub n equals a sub n minus 1 times 4. And if I really wanted to, I could go a sub 1 equals 1, and that would actually work with recursive. But if I'm going to the a sub 0, I would take 1 divided by 4 and get 1/4, or 0.25. Okay? Alright, number 19, the number of black tiles shown. So we have 1, then 2, then 4. Okay. It doesn't say if it's the beginning or what, so we can assume that that's the starting, or not the starting, so the first term, so we go back to the 0, we divide by 2 and get 1/2. So a sub 0 equals 1/2, or 0.5 for your decimal lover. Then a sub n equals a sub n minus 1, and we're timesing by 2, aren't we? Okay, now 20, we're dealing with a bracket here, okay? So, and with this, that's the start of the term, so we could consider this to be the beginning, the 0 term. So at the 0, we have 32. Let's actually write this in a different color. Okay, so at the 0, we have 32 teams. After the first round, we're down to 16. Yep. After the second round, we're down to 8. Third round, we're down to 4, also known as the quarterfinals. Okay. Then we're down to the 2 at the 4th round, and then finally at the 5th round, our winner, which is 1. So a basic single elimination bracket system. But a sub 0 would equal 32, because that's where we start. Then a sub n equals a sub n minus 1, and what are we doing? Well, we're dividing by 2, so I could write divide by 2. But we could also think of it as timesing by 1/2. Okay? Alright guys, so there we go. Again, it doesn't matter if you're given a story problem, a sequence, a picture, whatever information you're given, it all comes down to finding where it grows, finding how it starts, and in the terms of recursive, making sure you write this part, how it grows, this part, where it starts. And that's all we need, guys.